All right, nothing to see here. So as I was saying, I was encouraged to use the shameless baby slide. Now this is not a shameless baby. This is actually my seven-month-old child. I'm the shameless one because I've shamelessly handed my child over to Red Hat marketing, clearly. But hopefully, if at the end of this presentation you say, "Wow, that content really sucked," at least you can think about the cute baby, right? My material is based on systems thinking, right? Which clearly I borrow from works like the Phoenix Project, which borrowed on the work, the goal. But the overall idea is that manufacturing and IT move only as fast as the slowest component. And that optimization anywhere but the bottleneck is an illusion, right? So if you try to implement DevOps, you might be deluding yourself as to whether you're actually getting any benefits out of it. And so where's your bottleneck? Where is the bottleneck in your infrastructure that could be hindering you from effectively deploying DevOps? Right there. Basically, you most likely, if you're like most organizations, have a person or a thing that is backing up other persons or things from getting their work done, and they're hindering other person or things from completing their work, right? The idea is that this is your work in progress. Because of this hindrance, because of this bottleneck, you have a very large work in progress, which diminishes the effectiveness of your overall organization and can diminish the benefits of DevOps. But what is this person or thing in most organizations? It's this guy. If you look at the way most people run their infrastructure, and earlier today it was talked about cultural hindrances to deploying DevOps. Culturally, infrastructure people are very different, and most organizations have one or a small number of heroes in their organization that are responsible for designing, deploying, and maintaining the infrastructure. That's the go-to person in the infrastructure. Problem is that heroes are in high demand, right? Everybody is the most important person in the world, and they need something now, and that keeps the hero often from accomplishing the real priorities of the organization because everybody has a priority of their own. The other problem is that both bosses and recruiters like heroes. If this person is responsible for handcrafting the configurations of that infrastructure depending on the needs of that day or the noisiest customer of that day, they've got in their head all of what composes your infrastructure. And if that person leaves the organization, either voluntarily or involuntarily, a lot of your operational capabilities leave that organization as well. I apologize for such a long stride, because it's, but I'm getting my steps in, so that's good. Now, what do we do? I mean, if you look at sort of normal systems think or the goal type thinking, you run at the speed of the bottleneck. That reduces your work in progress, which overall adds efficiency, which is good. I might stop pacing because I think the camera guy's probably going to get mad at me. You run at the speed of the bottleneck, it reduces your work in progress, and it increases the overall efficiency of your organization, but you don't address the cultural issues that I talked about, and you don't improve really like you could. So what's the other option? Basically fix the bottleneck, automate the bottleneck. Essentially, you take your hero and you translate them into code, essentially hero as code, right? You take all of the experience, all of the knowledge, all of the anecdotal experience of that hero, and you translate it into code. Essentially, you define the intent, the policy, and the architecture of your organization or of your organization's infrastructure in a device-independent, vendor-independent way. And then you take that code and you insert it into, again, the virtuous DevOps process. This does two things for you, right? One, it as I said, includes infrastructure in your DevOps process along with all of the other the other code that really define what your organization's about. Most organizations aren't about infrastructure. They don't serve their citizenry or their customers with infrastructure. They do it with code that hands out their data, right? That's how they, I guess you don't want to just hand out their data, right? You want to do something useful to it. But that's how they serve their customers. But you can also, a secondary effect is your infrastructure benefits from being code, and inserting that code into a DevOps or at least DevOps-like process. It gains revision control and configuration management, which most organizations I talk to don't have. It gives you it ensures you an ongoing steady state because that code defines what the end state of that infrastructure should look like, and you can constantly look at your infrastructure and make sure that it still maintains the integrity with respect to that definition. It also gives you automated testing and to reduce human error. I mean, imagine every time you push out a change, a small change in the network, right? You can test that change to at least be reasonably assured that it's not going to mess something up. And then if it does mess something up, you can simply step back to the revision before it and at least put things back to a known good state. What it allows you to do, or what it allows your IT staff to do, is it allows your developers to, in code, define what they want from the infrastructure. Not indefinite pronouns, but code, very specific code. And then your operations folks can define how they want that intent translated into the infrastructure. And then your security folks can look to see exactly what's going on, right? There are not these snowflakes around, there's not this unknown in the infrastructure, and they can secure that, and they all work together to give you a secure infrastructure. Now, I'm not against heroes, right? I used to be a hero. Well, I knew the hero really well. Well, he was around the corner from my office. We said hi. But still, I'm not against heroes. That's the point. So how do we do this? Or at least, how am I going to talk to you about doing this? Basically using Ansible. So you've probably heard of Ansible right now, but I'm going to give you a quick intro nonetheless. Ansible is a simple automation language that can perfectly describe, you can tell this particularly is a marketing slide, right? Because perfectly describe an IT application infrastructure and playbooks. It's basically two parts, right? There's Ansible Core. Ansible Core is the playbooks. It's the playbooks that does all the real work. And then Ansible Tower is a way of controlling, securing, and managing those playbooks. And as a benefit, it gives you an API for doing all of that. Why is Ansible uniquely suited for this task? Well, one, it's really simple. You don't need to know Python to go automate your infrastructure. It's easily readable YAML files or YAML format that any ops person, I would contend, can get up and doing useful things in a day. It's powerful in that it has over 1,000 modules contributed from open source, contributed from Red Hat, contributed from other places that enable you to do things on the things, right? It's the modules that translate this intent to the infrastructure. And most importantly, it's agentless. It doesn't require any kind of agent on the end. If you can SSH to it, you've got a CLI, a Python binding, an API endpoint, whatever, you can automate from PDUs all the way to the application. So how do we use Ansible? As I said, we describe our intent, right, the end state of that infrastructure that we want to seek in a playbook. And then we take that playbook and apply it to our inventory. Now, that inventory can be a flat file. It can pull from our CMDB. It can pull from the inventory in AWS or OpenStack or whatever. It can dynamically generate that inventory from wherever you want. It takes our intent, and it takes the host to which we want to apply that intent, and then it uses modules through an API to actually deliver that intent to the end hardware. It's not meant to be an Ansible tutorial, but just hopefully so that you can see how easy a playbook is. Now, on that projector, you see the whole thing. On this, you kind of don't see the edges, but I don't think I use too much of the edges. But this is kind of a playbook that does real, I would think, useful things. So a playbook has tasks in it, essentially plays that are run in order. And I've got two types of tasks here. One of them is, and in particular, this is a network thing, right? So NXOS is Cisco's operating system for their data center switches, right? But the overall theme is it's an infrastructure thing. And network people are probably the worst, let me tell you, with respect to how are they doing what they're doing, right? The handcrafted configurations. And I'm not a network person. But so we got two types of modules here. An NXOS config module, which you kind of have to know, right? The configuration bits to do something. And then we've also got what I call more of a declarative module, right? We don't really know how it's done. We just know that in this case, we want to set the NTP server on this end device to these name servers, right? And so what we have here is a list. This is a simple list. And I iterate through that list, and I go and say, hey, I want to make sure that this device has this NTP server, and I want to make sure it has this NTP server, right? Hopefully this is all easily readable. Intuitively obvious to all but the most casual observer. And then when we run the playbook, you can see it actually trying to meet that end state. So I've run this playbook before, clearly, and so right here, you don't see it over here, but it says okay, okay, right? It says, I've already reached the end state for these things. I'm not going to worry. I'm going to leave it as it is. I've reached the end state for this, but not this. I'm going to go ahead and change this. And if I ran this again, it should say everything's okay because it has reached that end state. And so I can always check that my infrastructure is at that end state. And when you go about writing your Ansible, what you want to do is you want to decouple the definition of your infrastructure from the implementation of that infrastructure. You want an infrastructure or a device vendor agnostic schema that you then apply in the appropriate way to your underlying infrastructure. That allows you to, for example, apply policy once. Define policy once and apply it to cloud, apply it to firewalls, IDS, operating systems, PDUs if you have policy on your PDUs, right? But at the end of the day, it makes our pipeline, our DevOps pipeline, a lot more capable because you can add all of the things to your DevOps pipeline. And really, it's your DevOps pipeline that is the great abstraction from the infrastructure. Infrastructure should be a don't care, and your DevOps pipeline should be able to do anything to any infrastructure. So you can push out playbooks that, among other things, will automate your infrastructure. You can push out VMs, right? You can push out containers onto OpenShift, for example. You can push out code onto serverless or function as a service or what have you, right? You can have your entire organization in that DevOps pipeline, which gives you all the change management, and you can fast fail and all these kind of things, right? Goodness abounds. In addition, you can API all the things because Tower allows you to call these playbooks through an API. You basically can give your entire infrastructure an API to do interesting things like, for example, customers spend millions of dollars on log analytics platforms like Splunk and Elk. And generally, all they're doing is, they're the smartest platform on the network, and they're just gathering data, and they're just sort of alerting on this data. Well, you give your entire infrastructure an API, you can then do things based on the intelligence that these log analytics platforms have. So if you see something bad, you can respond to it. If you see something that needs to change, you can respond to it. It really increases the agility, small a, of your organization. Which brings us to the Open Service Broker API. It is a mechanism, it is an HTTP interface between services and a marketplace in platforms such as OpenShift or Kubernetes or Cloud Foundry. For service brokers. So these service brokers advertise, their wares into the marketplace and then respond to requests from the marketplace for their particular service. Essentially, what it does is it provisions, it binds to, it unbinds from, and deprovisions the service. Of course, you want to use it in between the bind and unbind, right? But it gives you the ability to do lots of neat things in your infrastructure. So if you can write Ansible to do it, and you can usually write Ansible to do it, you can then make it a service from your platform. And you can make that service available to your customers. So for example, things like firing up load balancing in physical load balancers. that tends to be something that an infrastructure person has to be in the middle of. And so kind of these DevOps, these DevOps processes will either just sort of wait until that's done, or they'll just simply not include the infrastructure, not getting the entirety of the testing that they can get from the process. Another thing you can do with it is firing up services in clouds like AWS. So from OpenShift specifically, you can fire up RDS, or you can fire up, well, I'm not going to use, I guess, a lot of load acronyms, right? But you can fire up databases, you can fire up MapReduce, you can fire up all the services that these clouds offer, giving you a granular way to do hybrid cloud instead of sloshing large applications all over. You can pick what service is best to locate wherever you want it. So the complexity is specifically when you're, for example, firing up services in AWS for this specific task, but in general, right, for all of your development needs, is sure you can fire up the service, but there's still infrastructure around that service. So in AWS, for you to fire up a service from the Open Service Broker, you need to have a VPC. You need to have subnet. So that's usually a person. Now, cloud makes it a lot easier. You could use a CloudFormation template for this as well. So this is not as hard of a problem to solve, but Ansible can solve this problem just fine too. So here's just some example of some Ansible. Again, intent-based, we don't actually need to know how to do this with the CLI or the clicks on the mouse, right? We just tell it what we want to accomplish, which is create this network, which essentially creates this VPC, create this region, create this subnet, which creates that subnet, and I left out the gateway because it was off, it's down here. But, and we automatically provision that infrastructure in which to put that service to do what we want to do, right? But wait, there's more. So you can actually, because of its ability to change the infrastructure, you can also, in the case of OpenShift in this particular example, we can actually provision the storage, we can provision the networking, we can provision the servers, and then push OpenShift on top of it, and then build our linkage to the cloud, and then the VPC. We can do the entire thing. So I've got customers, for example, when they're testing new versions of a platform, or they just want an ultra-sterile environment to test their code. So as part of your DevOps pipeline, you can provision everything, dynamically provision everything, again, from the PDU all the way up through the hardware, the platform, the application, the cloud, everything. Giving you a very, very, I probably should have said that on this slide. But it gives you a very, very capable pipeline, right? You can basically automate everything. Again, automating the hardware, the platform, the application, and the service. So if we kind of put this into a complete picture, again, hybrid cloud is a tricky thing, and I'm not sure I've seen lots of great examples for hybrid cloud, because when we think about hybrid cloud, we think about, again, sloshing whole applications to and from the cloud. That usually doesn't happen, right? Now, microservices give us a leg up, so you can locate different microservices, and that's what we've done here, or different microservices in different places. And so we're running microservices close to, let's say, some piece of data or a large pool of data that we don't want to move, doing some back-end processing. But we have to serve our customers, so we have some public tier with some more microservices that accept the requests from our users. And they might do some Elastic MapReduce and some Redshift and some of these other things, right? But we need a way to load balance across it, so we can reach out and we can configure Elastic Load Balancing, we can configure our DNS, we can configure our content distribution network. We can configure everything automatically. And so if you wanted to test the entire application from stem to stern, you can automate each one of those things. So my contention would be that it delivers more the benefit of implementing DevOps in your infrastructure, which is a good thing. And frankly, I didn't practice past here, so I'm just going to stop, if that's okay. And I'm going to ask if there are any questions. That's usually either very good or very bad. I'll go with very good. But I appreciate your attention. Thank you very much. Have a good day.